So just in case you don't remember what this looks like, let's put the price of the product on the vertical axis, the quantity produced and the quantity demanded on the horizontal axis. So we would have a downward sloping demand curve, something like that. Notice that what this tells us is that for this firm to sell more output, it must reduce the price of its product. Not just the incremental product, it must reduce the price on all of its products. So notice we're not assuming that this is a perfectly discriminating monopolist. This is just sort of your general monopolist who has to charge a single price in the marketplace. Okay? So downward sloping demand curve. Obviously, how downward sloping this is, how steep this curve is, depends upon the price elasticity of demand. Right? So the steepness depends upon what kind of product it is and what the taste and preferences of the consumers are. And that'll tell us then how much market power, pricing power, the monopolist actually has. Okay? Now, it's also the case that the marginal revenue curve is downward sloping and always lies inside or underneath the demand curve. Okay? So the marginal revenue curve is telling us what is the incremental revenue that comes from selling that last unit. Now, the reason that it's more steep, has a steeper slope than the demand curve is the assumption we made before. If you're not a perfectly discriminating monopolist, you have to lower the price on all the units that you're selling. So the more units that you're selling to begin with, if you want to sell one more, you've got to lower all those prices. So you're losing revenue there, lower price on the units that you were selling, and you're only getting the incremental amount on that extra unit that you have sold. So the marginal revenue curve will always be steep, unless it's perfect, unless it's horizontal. It will always be steeper than the demand curve and always lie underneath it. So notice that if, and this is an if, we don't know where this actually comes from, if this was our level of output, then there are a couple of things that we can say. It would make sense then, if we're producing Q naught, we can charge price P naught. That will maximize our total revenue. Notice that our revenue then is given by P naught, the vertical axis, times 0 to Q naught, the quantity. Price times quantity, that tells us our total revenue. However, our marginal revenue curve is way down here. So to sell this last unit, so from Q naught minus 1 to Q naught, is only going to bring in this much incremental revenue. Much less than, obviously, the total revenue, or much lower than the total price. So, again, just highlighting, when we think about what this relationship means, or is, we need to know how many units we're already selling. Okay, so this is our quantity, and we need to know the slope of the demand curve. As we'll see in just a minute, we're going to give that slope a parameter called minus b. One of the things that we would like to find out is how big is this difference between marginal revenue and price? What determines how big it is? Notice that as we go to smaller and smaller quantities, these two curves come together. So what is it that actually determines the distance between marginal revenue and price? Now, partly that's going to depend upon what the slope of the demand curve looks like. Remember, for a perfectly competitive firm, the demand curve is horizontal and is exactly equal to the marginal revenue curve. So there is no distance between the two. It's only when we have a downward sloping curve. So how elastic or inelastic the demand curve is will be important. So let's start with this demand curve. This is just a linear demand curve. So we've got quantity initially sold, and our price per unit, minus b will be the slope of our demand curve, and a will be that vertical intercept. How many could we give away at no price? Yes, a lot. Okay, so we've got a linear demand curve. If that's our demand curve, we don't have to worry about how this is actually derived. It turns out that this is the equation for the marginal revenue curve, which we can rearrange, and then we can see that the difference between price and marginal revenue, the distance between the demand curve and the marginal revenue curve at any given quantity will depend upon the quantity we're already selling and the slope of the demand curve. That's what it depends upon. So notice that the larger the quantity is for any given slope, but the larger the quantity is, then the bigger the difference has to be. The steeper the slope, also the bigger the difference. The flatter the slope, the smaller the distance. Okay, so this then tells us something about the relationship between the demand curve and the marginal revenue curve. Now, of course, as you know, we can look at this diagram. We don't know that we're at Q naught, right? In order to find where we want to be producing, we need some more information. And what we really want to think about here in terms of the additional information is what do our cost curves look like, our average and our marginal cost curves. Now, remember, we're operating under the assumption that we have economies of scale. So if you have large fixed costs and relatively low marginal costs, then as you increase production, your average cost per unit will be declining. So our average cost curve will be downward sloping. And the marginal cost curve, actually it says is also downward sloping, generally is, doesn't have to be. As we'll see in just a minute, I'll draw you a diagram in case this isn't remembrance to you, bringing back fond memories of micro. So here we're going to have our average cost curve. So typically, an average cost curve might look something like that. Okay. Now, because we're talking about economies of scale, we're primarily interested in the average cost curve up to this level of output. That is where average costs are actually falling. So notice, as average costs are falling, as we increase output, we're seeing cost decline per unit, and for a fixed price, I'm not saying price would be fixed, but if the price were fixed, that would give us a larger profit. Now, the marginal cost curve will look something like that, where marginal cost crosses the average cost curve at the average cost curve's lowest point. Now notice, if we're operating out here, we still have economies of scale in terms of average cost, but we could actually be on an upward sloping portion of marginal cost. When the average cost curve is falling, marginal cost will always be less than average cost. When the average cost curve is declining, the marginal cost curve will always be below it. When the average cost curve is average cost curve is rising, marginal cost will always be above it. Now let's think about how we can do, in terms of some basic math, some cost curves here. So again, we're going to use a linear cost function just to keep things very simple here. So we're just going to say, okay, our total cost of production, fixed costs, right? We got to account for that big facility that we built, plus our marginal cost of output times the level of output. Now, one of the things that we're going to assume here, which I did not draw in the earlier diagram, but let's just assume for now that this is a constant. Okay? So you can think of Microsoft. How much does it cost Microsoft to make another copy of whatever, right? Some amount. Probably doesn't make any difference, right? Whether they produce 100,000 of those or 1,000,000 of them. That the average cost of producing another copy of some piece of software is fairly constant. If you thought about making pharmaceuticals, same thing. Cost of making more pills doesn't change if you make 1,000,000 of them versus 500,000 of them versus 2,000,000 of them. So that's all we want to say here for right now. Let's just play around a little with this. So this is our total cost. We could call this total cost curve, right? Fixed cost plus our marginal cost. So if that's the case, then our average cost per unit is just our total cost divided by our output. Right? Total cost divided by our output. And we could do this substitution, or do a substitution, and find that it's just fixed cost divided by our output. So notice that this variable will decline as quantity increases. And then we've got our constant marginal cost sitting here out at the other end. So in terms of what we've drawn here, or assumed, we've got a constant marginal cost at C, and then our average cost will look like that, where this value up here is our fixed cost, and as quantity gets larger and larger, we'll asymptote to that fixed, or to that constant marginal cost. Okay. So now, all we have to think about is profit maximization. Now remember, when we had perfect competition, we were assuming profit maximization. Even with imperfect competition, we're going to assume that businesses want to maximize their profits. Okay? So with profit maximization, we simply want to set marginal cost equals to marginal revenue. So here we've got price, average cost, marginal cost, and quantity. Here's our demand curve. Here's our marginal revenue curve. Here's our average cost curve. And notice, because I have the average cost curve moving back up, it also suggests that we do not have constant marginal cost. But the marginal cost curve looks like that. So where does this firm produce? Remember, the wonderful thing about imperfect competition, where a firm faces a downward sloping demand curve, the firm can choose its own production level, and it matters. In perfect competition, it doesn't matter. You can produce as much as you want or as little as you want. You're not going to affect the price. But downward sloping demand curves, how much you decide to produce also determines the price that you will be able to charge. Well, profit maximization says, okay, we want to be at point A. Right? Marginal revenue equals marginal cost. That says we want to produce QM for monopoly output. At that output level, we come up to our demand curve, and we see that we can charge a price of PM, the monopoly price. So that's point B. So point A also tells us where marginal revenue equals marginal cost. And then point C, for that output level of QM, this tells us what our average costs are, ACM. And this difference are the monopoly profits. Which will not be competed away, right? If you're a monopoly, it's not like you can have entry of other firms to help compete away those monopoly profits, which is why, of course, you always want to come back in your next life, after you graduate, that is, not after you die, as a monopolist. Okay, so what does all this have to do with international trade? Okay, so we've got monopoly firms, right? Hopefully all of you remember this from microeconomics. No? What do you mean no? You haven't gotten to monopoly yet, right? That'll teach you to take it at the same time. Okay, so there's an interesting controversy in international trade called dumping. Now, there are many, many different definitions of dumping and what it actually means. We're going to use one of those definitions, although we could show it under the other definition. So the more popular definition, and the one that we're going to use, is that dumping is essentially price discrimination between the domestic market and the foreign market. That is, that you are going to charge a different price in the foreign or export market, different meaning, by the way, lower, than you will in your domestic market. Now, domestic consumers might complain about that. Why are you selling it to foreigners at a cheaper price than you're selling it to us? And foreign producers might also complain, how come you can sell it in our market at a lower price than you're selling it in your home market? You must be using your monopoly profits that you're driving at home to subsidize these sales in the foreign market. So foreign firms feel like they're under unfair competitive advantage, or unfair advantage, facing a monopolist who's exporting at a lower price. And domestic consumers feel like they're being hurt as well. Wow, that doesn't feel very good, does it? The more legal definition of dumping has to do with charges that you are selling in a foreign market at below your cost of production. Below your cost of production. Well, we could show that, I mean, if we wanted to get into that. But the more general case is the price discrimination between a domestic market and a foreign market. So what I want to demonstrate now is, A, why would a monopolist do that? And two, if we understand why, does it make sense for a monopolist to do that? Does it turn out to be the profit-maximizing behavior for the monopolists themselves? So that's where we kind of want to go with this. For this to work, the industry has to be imperfectly competitive domestically. Good, not a problem, right? We have a monopolist. And the foreign and domestic markets must be what we call segmented. Now remember, we're selling at different prices in different markets. So what segmented means is you cannot arbitrage that opportunity. You cannot buy the product in the foreign market at a lower price and re-export it back to the domestic market and sell it and therefore compete against the monopolist itself. So there's no re-export or arbitrage opportunities between the markets. So that's what we mean by segmented. So in this example, it says simple. I hope you will find this a simple example. I guess this is redundant, right, to say a single monopolistic firm. All monopolistic firms are by definition single, right? So I guess I should scratch that out. Okay, and we're going to have two segmented markets. An imperfectly competitive domestic market is also somewhat redundant. If we have a monopoly firm, we're by definition imperfectly competitive. But here we're going to make a slightly different assumption about the foreign market. And that is we're going to assume that in the foreign market, we are just one of many firms, and we face basically a competitive marketplace. So there may be a lot of reasons for that. You could be a monopolist in say, a relatively small country, which would by definition have a relatively small industry on a global standard that may only be big enough to support a single firm. But if you go into the external marketplace, if you're exporting into a large country, think of the Euro region or China or the US, there might be very large markets might be able to support many more firms. And so the competition in that foreign market could be much greater once you enter it than it would be in your domestic market. It's also the case that for most firms who produce and export, that those export sales are a relatively small portion of their total production and sales. And therefore, being a much smaller competitor in the export market, they also end up being more like a perfectly competitive firm. So we can also say this the following way. This firm is a price setter domestically. So in the home market, this firm can set the price, but it is a price taker in the foreign market. Okay, so let's look at the domestic market first. So this is going to be the domestic market. Pre-trade, domestic, let's call it our turkey market. Our demand curve, our marginal revenue curve, and our marginal cost curve. Now, we haven't added the foreign market yet, but I want to highlight that this is the domestic demand curve, the domestic marginal revenue curve, but it will be the total marginal cost curve. So the cost curve that we're looking at doesn't depend on whether or not we're selling it domestically or abroad. We're making it all here. So whatever our production is has to be done against this marginal cost curve. So before we enter into the foreign market, okay. People who make these pins are obviously price setters. Okay, so this is our monopoly price and our monopoly quantity. Okay, so everybody's happy here? Now, let's just assume that this is what we had before. So in black, I just want to highlight where we are. Okay, now we're going to add the foreign market. Now remember, in the foreign market, we are a